So in the last class we discussed about the linear regression, right?
Yes, correct.
So do you have any confusion or doubt or any query regarding that?
Um, no, I am good.
Okay, so let me share the screen. Can you see the screen?
Mm-hmm. Yeah,
Right?
yeah, I can say.
So we have seen this, right? On the last function,
Yes,
last
yes.
class, we saw an algorithm which was your supervised learning. That came from your
Yes.
supervised learning, right? And
Mm-hmm.
specifically it was a regression problem, like it regressed you the value, right? Like the salary
Mm-hmm.
predict, like it predicts your salary,
Mm-hmm.
like some certain value with that was your continuous, right?
Mm-hmm.
So what we will do in today's class, we will be seeing a classification algorithm, right? So
Mm-hmm.
algorithm that will be basically helpful for your classifying your categories, okay? Like your
Mm-hmm.
male or female, like your dog
Okay.
or a cat or any like
Mm.
finding the basically distinguishing between two variables like student or programmer, right?
Okay.
Like so here to explain you how this works, let's take an example, right? So yeah, so suppose you are given with a your this data set, right? This very small data
Mm-hmm.
so that you can understand, okay? So oh yes, so on the first column we have a gender, okay, like female and male, okay? And on the second column we have occupation, student and
Mm-hmm.
programmers, okay? Whether the person is a student or the person is programmer, okay? So these basically these two are your categorical variables, okay? Sorry, independent variables, okay? Means your features, you may say. Wait a second. Yeah. Yes. So basically these both are your features, okay? Basically they will be responsible for this particular value, which is your label, okay? So like if the student is female and the occupation is a student, he is suggesting like to download PUBG, right? And if if the gender is female and the occupation is programmer, he is in GitHub, okay? So like this we have a certain data, and now we want to create a model that will predict on the basis of any given input. Like we will have certain a new input, suppose, okay, right? Suppose we have any input for gender and we have any input, new input for occupation, okay? And now we want our model to predict what will be the suggestion, like whether the person will pick PUBG, GitHub or WhatsApp, right? So this is basically our model, right? So we will be using a decision tree algorithm to solve this problem, right? Suppose say I am having a input value, suppose say male, right? The male is your programmer. So what should be the output? What should be the suggestion, right? So basically we have to create a model that will help us to predict this, okay? So if you see here, so your decision tree is basically very easy, right? So it is just your if statements. It is just your nested if statement, right? Like suppose if we will pick any feature like starting feature like gender or occupation, right? And then we will start moving to the down of the tree, like suppose say I say uh, for if the occupation is student, right? If you may see that all the student have just picked the PUBG, right? Here, so we can just say that if your occupation is PUBG student, your suggestion will be your PUBG. We don't want gender, we don't want to check for gender, what is the gender. Like female also is suggesting PUBG and male are also suggesting PUBG if the occupation is student, right? And for programmers, now we have to again create a nested if statement. Like if your occupation is programmer and your gender is your female, then the suggestion is your GitHub. Like here also programmer and here also programmer, right? The gender is female, they suggest to choose GitHub. Else, if the occupation is programmer and gender is male, he will be choosing WhatsApp. So this is how your decision tree, basic decision tree works, like the intuition behind decision tree, right? So this can be also written in a your if statement. So if you write this as a on a if statement, suppose in a Python, it will be look something like this, right? If your occupation is equals to student, right? If occupation is a student, just print PUBG, right? This will be your output, or you may say return PUBG. If the gender is female, right? Gender is female means see, if the occupation is student, right? Else, that means if the occupation is not student, right? That means your occupation is now programmer. Now in programmer you have two options. If the student is female, or the sorry, or the person is not female, that means male, right? The person is female, he will be choosing GitHub, right? So this is the way how you can write a simple way. But now the challenge here comes is how will you choose that in this if statement that you have to check for this occupation is equals to student, right? This will be a possible your query. Like how do we decide at the very beginning, like it's the conditional should be this, the condition should be this, occupation is equals to student, then you have to pick PUBG. So basic the decision tree, working behind decision tree is to figure out what are the feature, what are the categories on which the decision has to be made, right? This is your categorical variable. So here we are writing something like this. So your decision tree also works with your numbers, right? With your numerical variables. So in the earlier in the same example, like if you want to write this in a tree, right? The tree format. So you can write like this. First of all, we are taking a node, upper node, right? So it is asking question, is occupation student, and it will return two answers, right? It will say yes or no. If it says yes, it will return PUBG. Else, it will check for another condition. Is the gender female? If yes, then GitHub. If no, then WhatsApp, right? So this is how your tree can be made using this data. Like if it will be more complex, then your tree will become much bigger, and it will be also complex, right? So now let's take the same example, not a different example. This year a famous tennis data set, right? So in this data set you are having some variables, right? Features like outlook, whether the outlook was sunny, weather basically, or rainy or overcast, okay? And your temperature, whether the temperature was hot, mild, cool, right? And humidity, high, normal, low. I think high and normal only, okay? And wind, like weak, strong, right? Weak and strong. And this play will be your label now. This will be your label. This play category, right? These are your features. On the basis of this, you have to predict whether the person will choose to play or not, right? So can you try to create a decision tree by looking at this diagram, by this data set? Means like we will start, yeah. So think like let's start from say outlook, right? So if the sunny it like for overcast, like let's say for overcast.
Yeah, I will try this one as this one. Yeah,
Okay,
I will
so
try this.
so for trying, I will give you some another data set. I will explain you basically how it works, okay?
Sure.
Because I have prepared it. So for trying you, I will be giving you another data set, or you can try it on your own. Like you can search like for the data set for your decision tree, right? Then you may try creating it, okay? So since now let's look on the this sunny, right? If you will see this sunny, right? So for some value like sunny is also giving us no, and for some value it also give us yes.
Yes.
So it cannot be like at the starting we cannot take say start with sunny, right? Like
Mm-hmm.
uh, because for some value yes also gives for playing no, and right for if it returns false, right, if the weather is not sunny.
Mm-hmm.
Means what basically I'm trying to say is for some value of sunny
Mm.
the output of
Yes.
plays no, right, and for
Yeah.
some
Yeah.
value of
Mm-hmm.
sunny the output of value is yes also, right?
Yes.
So
Yeah.
we can't say
Mm-hmm.
that this category can be at the top. Let's look for overcast, right? Overcast is
Mm-hmm.
saying yes, overcast is
Mm-hmm.
saying yes,
Mm-hmm.
overcast is saying yes and yes. So that means if you overcast is yes, that means a person can play,
Mm.
and if the overcast is no, that means the outlook is sunny or rain. Now it will check
Other.
if the sunny or rain, like okay. So like this way
Mm-hmm.
your decision tree takes decision and creates a tree, right? So now let's look how your tree looks like, okay?
Mm-hmm.
So this is your tree will look like. We will start with looking at outlook, okay? First of all we will look at outlook. If the
Mm-hmm.
outlook will have any category from this like sunny, overcast or rainy, if the your outlook value is overcast, right,
Mm-hmm.
if it is yes, so then it will directly say yes, like you can
Yes.
play,
Yeah.
right?
Mm-hmm.
So if the value of outlook is not overcast, like it is sunny for example, okay, so
Mm-hmm.
now it will check for windy directly. It will not check for temperature, it will not check for humidity, okay, it
Mm-hmm.
will directly check for wind, okay. If the outlook is sunny, suppose say here sunny, like it check
Mm-hmm.
for wind weak, right?
Mm-hmm.
So windy, I think the a little data is missing, or so let's take the example of rainy, right? So this suppose your rain, okay,
Mm-hmm.
we will check for humidity in rain, okay. So if the
Mm-hmm.
humidity is high for rainy, okay, that means
Mm-hmm.
you can play. Like here
Mm-hmm.
you have humidity high, that you can
Mm-hmm.
play. Here it is returning no. I think there is some error in weak high. Yes, yes, I think there's a little humidity. So means basically you got an idea, right? It will return you some
Yeah.
two values like yes or no, and then it will create adding the nodes basically, right? Or you may call it
Mm-hmm.
branches, okay. This will be
Mm-hmm.
called as your branch or your subtree, right?
Mm-hmm.
Subtree, or also known as branches, okay. Now like for your example, you have a input query point like your rainy, and this is your input, okay. On outlook you have rainy, on humidity you have mild, so on temperature you have mild, on humidity you have high, and windy strong. So it will check for
Mm-hmm.
rainy, humidity, and then it will check humidity, right? Humidity is high, and it will check high, yes, so therefore you cannot play. So your it will
Mm-hmm.
predict that you cannot play, right, on this query input. This is your
Mm-hmm.
input
Mm-hmm.
query, right? So now what if your data is numerical? So do you understand how this works for your categorical data, how this decision tree
Yes.
works, right?
Yeah. See,
Basically the
decision tree. Mm-hmm. Yeah. Here my doubt is how can we choose that futures? Which one? So can you scroll down, please?
yeah,
So this one you said like first overcast. Okay, I understand there is outcome only we need yes. So subset is fine. I mean subtree is fine. The other one, if we started looking like sunny, you said like we don't take care of temp and humidity. Directly we can choose the wind. These kind of thing, how can I decide?
yeah.
So which
So
future I? Mm,
so I would suggest you once you will I will suggest you an article, right, in this decision
sure.
tree. So you may go
Mm-hmm.
through it. It is a not advanced, but it takes some different concept, right? So it will take a little longer. So I just give you a
Yeah.
basic intuition in this lecture. Okay,
Okay.
so
Okay.
you may
Then
read that
fine.
and
Yeah.
you will get how the working behind the algorithm works. Okay, so at the end this happens, like it will give you
Yeah. Yeah. Now I
some
got.
outcomes.
Okay.
Okay,
Yeah.
yeah.
Basic.
So for let's take start for your numerical data. Okay, so now you have suppose some numbers, like you have a data iris data set, like your petal length and sepal length. Okay, so these are your numbers for your petal length, and these are your numerical data for your sepal length. Okay, and this will be your predicted value, like type setosa, versicolor, or virginica, right? And now we have to create a decision tree based upon this data, right? So now it will generate you some specific numbers, right? The greater than which you will have some certain outcomes, right? And this value is also generated using your algorithms. Okay, and how it is done, you may I will be giving you a article link, you may go
Sure.
through it. Okay, so it will show you the working behind of it. Okay, so
Yeah.
basically it will give you a value, that is
Mm-hmm.
this, right? And now we are checking for
Mm-hmm.
this value, like for petal length.
Mm-hmm.
If it is
Mm-hmm.
smaller than 2, then it will say directly yes, it is setosa. Like here it is smaller than 2, so it says setosa. Smaller than 1, setosa, right?
Smaller than, lesser than 2.
Sorry, lesser than 2, right?
Yeah.
Lesser than 2 is setosa. And if it is
Mm-hmm.
not, then it will check for sepal length. If the sepal length is lesser than 1.5, sepal length is lesser than 1.5, yes, then it's versicolor. Okay,
Mm. Yeah. Okay.
right? So now if you want to see it geometrically,
Mm-hmm.
yes. So these are the data points that I have plotted here, right? On the x-axis you have here petal length, and on the y-axis you have your sepal length. Okay, and these are the data points that are being plotted here, like on the petal length and sepal length, right? And now suppose you got any value at here, at this point, right? Now how will you say that whether this point, this x is your versicolor, virginica, or setosa, right?
Mm-hmm.
Am I missing here? Yes, I am missing here a page. So basically how it works is, it will draw a line. Okay, so here we have 2 at 2, petal length at 2, so it will draw a line at petal length 2. Sorry, here the line should be. Okay, so for the values that are smaller than 2, right, it will return setosa. So therefore any value that will fall in this part, these are your setosa, right? And now in this part there can be two, either they can be versicolor or they can be virginica, right? Now we will check for SL, your sepal length. We will create another boundary that will for your sepal length, like it is for 1.5, so we created it here, right? So if it is greater than smaller than sepal length 1.5, so it is your versicolor. So any point that lie in your here, smaller than 1.5, right? So these values are your versicolor below this line, right? And in this direction, the right hand side. And at last any value in this region, right, this will be your virginica, like it is greater than 1.5 and it is also greater than your 2. And now you
Lesser
may
than,
see greater
no,
than
greater.
2.
Yeah,
Yeah,
just
yeah,
opposite. Yeah.
yeah,
No.
okay.
Yeah.
So now if you may see that you got a input value here, right, you will plot it. It will be like you are given with some value like on the petal length and for some value for sepal length, and you plot it, and you find that this comes in this boundary, right?
mm,
and this
mm,
boundary
mm,
was of your virginica.
mm,
So by seeing the drawing the graph also you can visualize this problem. Okay,
mm,
that means your
mhm,
input value is your virginica.
mm,
Okay, so
mhm,
how this is how your this decision tree works for your numerical data. Okay, so let me just
mm,
give you a quick terminologies and then we will yeah, so I will be giving you some question like you may search them and find them, right? These are the basic
yeah,
questions on your
mm,
decision tree,
mm,
and after
mm,
that we will be seeing a code. Okay, so how this basically this exactly
mhm,
this problem can be solved with your decision tree. Okay,
mm,
we'll create a
mm,
model, machine learning model, and we will see
mhm,
for the that exact data. Okay, and your
mm,
terminologies are like this was your tree, right? At the starting
mm,
we have some conditional point
mhm,
that is called your root
mhm,
node.
mm,
Okay, so this root node will return you two values, either the value will be yes or it will be no. Okay, if the value is
mm,
yes it will return you so here at this point we specify it as splitting, right? This
mm,
condition thing, so this is referred as
mhm,
splitting. And then
mhm,
again once you get a different, it will be no another conditional statement, so it will be your branch. Okay, as I
mm,
explained you, a branch, or you may also say it as subtree. Okay,
mm, mm,
and the next node will be below your root node will be referred as your decision node. Okay,
mm, mm,
and the decision node will return you two output, and these are known as your leaf nodes, this and this.
mm, mhm,
Okay, so you may just keep them in your mind because it may be used while talking about
mm,
the same concept, right? So these are the basic concepts that come into mind when dealing with your decision tree. Okay,
mm, mm.
like how to decide which column should be considered as a root node.
Yeah.
Okay, the
Mhm.
same question I think that you asked.
Yes.
And another thing that you have to ask is how to select the subsequent decision node.
Subsequent. Yes.
Like once you
Subsequent.
selected
Yeah, I
this
will find
starting
that.
point and the subsequent
Mm,
decision nodes, and
mhm,
also how do you
mhm,
decide the splitting criteria, like how
mm.
do you find this value particular that it was 2,
Yes. Mm,
how you will find that criteria in the case of numerical columns. Okay,
mm, mhm.
so I'll be sending you this basically this notebook, and you may
Just
go through it. Okay, I think linear regression I sent you.
no, not yeah. Linear. Yeah. Can you go up?
Yeah,
Yeah, from here, decision tree. Yeah, I need from
yeah,
this until the we have it. Yeah,
yeah.
from
Okay,
decision tree. I think.
yeah, yeah. Okay, sure, I'll be sending it to you.
Mm,
Okay,
mm,
and now
mm,
let's quickly look to the this code, and then we have to cover
mm,
another machine learning model also. So basically we will cover three machine learning model. We have covered linear regression, right? And now we are looking at
mhm.
decision tree, and then we will look
This
at another classification model, that is basically your KNN. Okay, k nearest neighbors.
in